Hi, everybody. Thanks for joining the session today. My name is Brett Barwick, and I'm a principal software engineer with SIOS Technology, primarily focused on high availability for SAP on Linux. And today I'll be talking about how SIOS can help you achieve simple and reliable high availability for SAP in the cloud. So the first thing I'd like to mention is something that I'm sure most SAP customers are already aware of, which is just that SAP has mandated customers to migrate to the HANA in-memory database by 2027. And a lot of customers will go ahead and use this as an opportunity to migrate workloads to S/4HANA and start putting components of workloads in the cloud. In fact, according to a 2021 survey that was conducted by Syntax and the Americas SAP Users Group, 81% of respondents already had components of workloads in the cloud, and 73% of those that were still running entirely on-prem plan to add at least some cloud services within the next year. So a common question that we get from folks that are making this cloud migration is, do I really need high availability and disaster recovery in the cloud? I've got this SLA from my cloud provider that's guaranteeing me a certain amount of uptime. So isn't that going to be enough for me? Well, so cloud providers do a great job of keeping services up and running, but the fact is just any system that's that complex and interdependent is going to fail from time to time. And it's easy to find stories of blown transformers or bad config files getting pushed that bring cloud services down for hours at a time. The good news is that these things are rare, and when they do happen, they are usually isolated to a single availability zone, so meaning a single isolated cloud data center, or potentially just a single region. So if we're careful about how we architect our SAP workloads, we can mitigate against failures like this. And the fact that cloud services are going to fail from time to time isn't a secret. Cloud providers are very upfront about this, and they provide best practices guides, which are usually called their well-architected framework, that help customers develop workloads that maximize some of these key principles like operational excellence, security, reliability, performance, and making sure that their workloads are optimized for the cloud. And out of all these, I would like to focus on the one in the middle, just talk a little bit more about reliability. So if you go through the well-architected framework from all the major cloud providers, you look for common themes. I'll just point out a few that I noticed as I was going through. So the first is they all recommend that you have visibility into the health of your workloads. That needs to be built in such a way that the health can be constantly monitored, and your workload should be able to automatically heal itself if it determines that services have been compromised. So you want automatic recovery, automatic monitoring. The second is that cloud providers recommend that explicitly that you should architect for high availability and disaster recovery. And generally, the way you architect for high availability is just making sure that your workload is redundant across cloud availability zones, which again are just geographically separated data centers. And if you want to architect for disaster recovery too, then you're generally going to put a redundant copy of your workload in a separate cloud region. Again, just giving yourself more geographic separation across your fault domains. And the third recommendation is that you are regularly testing all of your recovery processes, be they automatic or manual. And ideally, you are maintaining a test environment that mirrors your production environment so that you can induce failures and see how resilient your system is. Whether it automatically detects the failure, can it automatically recover? And in cases where manual recovery steps are needed, how efficient is your team in terms of getting your SAP workload back up and running? Another thing that people generally think about when they think about availability and scalability in the cloud is, auto-scaling groups sitting behind a load balancer, or maybe containerized microservices. Just something where, things can scale up and scale down as the workload demands, Or if a component fails, you just kill it and then you spin up a new one and you continue on. And these kind of solutions are really good for stateless applications. So for instance, if you want to serve up a REST API. But the way that SAP application server components and like the HANA database are designed are inherently stateful. So not only do you need to be able to recover all the processes when something fails, but you also need to be able to recover the state of the system before the failure, just to make sure that you don't lose any transactions that were in progress at the point of failure. And generally, when you're protecting stateful applications like this, they kind of lend themselves more naturally to data replication for the redundancy portion, and then also high availability clustering, so for the monitoring and recovery portion. So speaking of that, I'll mention a couple of SIOS products here, and these are bundled as something called SIOS Protection Suite. The first is called SIOS Lifekeeper, and that's our product that handles all the monitoring and application-aware recovery and failover. It's available on Linux and Windows, and it provides protection for all levels of your stack. From, it can protect against OS failures, you can protect NFS shares, important file system mounts, virtual IPs, DNS entries, all the way up to your application and database layers. And the second product is called SIOS Data Keeper, which complements Lifekeeper. It's high performance block level data replication. So it allows you to keep a one-to-one copy of your important file systems, replicated from a primary system to your standby system, or to a DR site in a separate region. And I'll just point out that both of these are available on Linux and Windows. Data Keeper for Linux integrates into Lifekeeper for Linux. And on Windows, there's a standalone version of Data Keeper. And we also have Data Keeper Cluster Edition, which takes all the functionality of Data Keeper and integrates it natively into Windows Server Failover Cluster. All right. One of the great things about Lifekeeper are these things that we call application recovery kits. So you can think of these as kind of like plugins or supplemental packages that are provided by SIOS. And they just give you out-of-the-box protection for key infrastructure components or major applications or databases. So for instance, we have an application recovery kit that can protect all of your key SAP instances, as well as any SAP-supported database like HANA, Sybase, MaxDB, Oracle, DB2, etc. So some of the great features of these application recovery kits: number one, all of the resource creation and management is wizard-based. So when you go to actually create and protect a resource, you get walked through a sequence of dialogues, and generally you're just kind of selecting things from pre-populated drop-down boxes. And then at the end, it's going to validate all the selections you made. And it makes the resource creation process very smooth and streamlined. The second thing is, out of the box, you get all the logic you need for monitoring and automatic recovery of your applications. And that's been honed over 2 decades of direct experience with customers. And the third thing I'll mention is, just if we don't already have an application recovery kit, say you're running a custom application in your stack somewhere, as long as you can tell Lifekeeper how to start, stop, monitor, and recover your application, then you can create something called a generic application resource and literally protect any application, plug it into Lifekeeper just like any other resource, and it can become part of your resource hierarchy. All right, so now that we've looked at some of the products, I'd like to take a look at a typical highly available SAP deployment in the cloud. And we'll just kind of point out the key things as we go here. The first thing I'll highlight is just, we have on the left side, we have our end users. They're connecting to SAP services in the cloud through something like a customer gateway. And up top in the middle, we've got our production region where the whole production workload is running. But before we kind of zoom in on that, I'd like to mention, you'll notice here I've got a separate region, region 2, and it's being used as a disaster recovery site. and all of the important data and VM configuration information is being replicated to the DR site. And the exact mechanism that's being used for the replication could vary. So for instance, if you just need to replicate important data from some of your key file systems, you could use something like SIOS Datakeeper. If you want more of a kind of holistic cloud-based approach, you could use a cloud service. For instance, AWS Elastic Disaster Recovery, which was formerly known as Cloud Endure, if you happen to know it by that name. Or if you're on Azure, you could use Azure Site Recovery. And some of these cloud services are nice, actually, from a cost optimization perspective, because a lot of them allow you to not have to have running standby systems, that are always running in your DR site. They allow you, whenever a disaster happens, you want to manually kick off disaster recovery. At that point, then it will spin up all the cloud infrastructure you need, load all the important data, and then allow you to resume your workload in your disaster recovery region. Okay. But so the next thing I want to do is I just want to focus in on the production region where the production workload's running. And you'll notice here, like we talked about before with high availability, we talked about wanting to spread the workload across multiple availability zones. And so you can see here I've got availability zone A and then B, and redundant copies of my workload across both. On the left-hand side, you can see public subnets that I'm just using, to have internet access, and they also host a jump box that I can use to access my virtual machines that are in the private subnet. But the private subnet is where all the interesting stuff is. So first thing I'll do is just point out I've got an application server pool set up with a primary application server in my primary availability zone, and then an additional application server set up in the other availability zone. And technically, the application server is not a single point of failure for your SAP system. So it's good enough just to create a pool of application servers rather than really needing to have a highly available cluster. But somewhere where you do want to have a cluster is for something called the central services instance. And this houses two really important processes that are both single points of failure for an SAP system. The first being the message server, and the second being the on-queue server. And I'm going to focus mainly on the on-queue server because that is the source of, if you notice the arrow in the diagram, there's some replication happening. The on-queue server is what's doing that replication. So the job of the on-queue server is to manage something called the lock table. And that just makes sure that you are preventing database collisions when you're running your SAP transactions. One really important concept is that you never want to lose the lock table if possible. So, if you lose the lock table, then when you recover the on-queue server, you're going to lose all the transactions that were in progress when it failed. So SAP provides a mechanism to replicate the locks from the lock table to another server, so you have a redundant copy. And so here in the primary availability zone, we have the central services instance running and the on-queue server running inside of it. And it is continuously replicating its lock table to something called the on-queue replication server, or ERS instance. And that's running on the standby system. It is very important, and we'll see this come up in a demo in just a few minutes, but it's very important that the central services instance and the ERS instance are always running on different servers when possible. Again, just to maintain redundancy of the lock table. All right, so in terms of what we're using in Lifekeeper to protect the ASCS and ERS instances, we're using this SAP Application Recovery Kit. And this is certified by SAP for use with NetWeaver and S/4HANA. And it just gives you out-of-the-box protection, monitoring, automatic recovery, et cetera, for all your key SAP instance types. So not only does it monitor and recover all the instance processes that you need it to, but it also monitors all the supporting services. So your SAP host agent, SAP start service, et cetera. And another really nice feature is that it will automatically try to keep the ASCS instance and ERS instance running on different servers when possible. Okay, and we'll see that in a demo in just a few minutes. So the second component that it's important to cluster is the database. And in this diagram, I have HANA pictured, although technically until 2027, you could use any supported SAP database, like, again, Sybase, MaxDB, DB2, Oracle, etc. But here I've got a 2-node scale-up HANA database cluster pictured. And the primary site is replicating the contents of the database to the secondary site using HANA system replication, which is a mechanism that's provided by SAP. Okay, so that cluster is being protected by Lifekeeper, and specifically it's being protected using the HANA Recovery Kit. So some nice features of the HANA Recovery Kit, just like the SAP Recovery Kit, it monitors all the key processes you need and the supporting services. But some stuff that's specific to HANA, it also monitors the system replication status, and it will prevent you from promoting the secondary database to become primary if system replication is not in sync. The idea there being that it prevents accidental data loss by accidentally trying to promote the secondary before all the data has synced. Another nice feature just of system replication in general is the fact that it replicates from a running database to another running database. So with HANA, you get to have a running, hot standby database waiting there. So if you switch over or fail over, you don't have to wait for the database to start up. It's already running. You just promote it to the primary, and then it's ready to use. Okay, and then finally, I also just want to point out that the HANA Recovery Kit supports the use of the HANA Takeover with Handshake feature. And this is a feature that SAP provides just to minimize downtime when you're performing a switchover in a scheduled maintenance window. Okay, so now that we've taken a look at what a typical highly available SAP deployment looks like, I'd like to just point out a couple common challenges that we hear from customers. The first being the need for flexibility. So if we go back to that 2021 survey, and you look at responses from users that already had components of their workloads in the cloud, you'll see that 25% were running in public cloud, 28% were in public cloud, and 46% were in hybrid cloud. And you had 38% using a single cloud provider, but 61% were spreading components across multiple cloud providers. So you can see, that customers are kind of hesitant to put all their eggs in one basket. They may want to spread pieces of their workload across cloud providers, or even kind of keep one foot in their data center just to retain some control of some of their critical infrastructure. So that's one of the nice things about SIOS products is we have a wide range of supported OSs and configurations. So remember, our products are on both Linux and Windows. We support all major enterprise distributions of Linux and pretty much every version of Windows Server under the sun. You can run our products on-prem, virtualized, in the cloud. You can run a multi-cloud, hybrid cloud, etc. So you end up just getting a common high availability experience across your entire server landscape. The second challenge that we hear from customers is about, just the perceived complexity of introducing high availability. I've got to now set up a cluster. I've got to manage replication, and also customers just kind of being frustrated with past experiences with high availability software. So what I'd like to do is I'd like to just show a couple short demos. Number one, what does it look like to actually create some of these SAP resources in Lifekeeper? Just kind of show how easy that process is. And then number two, what are some of the monitoring and recovery features that Lifekeeper has when it comes to SAP instances? So I'm going to go ahead and look at this ASCS ERS cluster that I have running in the cloud. And you'll see that I already have some resources created. I have 2 IP resource hierarchies. This 10.10.10.10 IP is going to be used for the ASCS virtual IP. And then I've got this 10.10.10.11 IP for the ERS virtual IP. And another thing I'll point out here is that I don't have any other file system resources, NFS resources, and that's because I'm using a cloud file sharing service. So that's going to make my hierarchy particularly simple. All right, so I'm going to right click. I'm going to go to create resource hierarchy on node A. I'll select SAP from the drop-down box, go with the default intelligent switchback type. And Lifekeeper has scanned my system and determined that there's exactly one SAP installation under SID SHC. So I'll select that. And in that installation, I have 2 instances, ASCS 10 and ERS 20. And we're going to go ahead and protect the ASCS instance first. So the next dialog that will come up, Lifekeeper has scanned the system. It's seen that I've already created some IP resources. And it's going to ask if I want to go ahead and use this IP resource for the virtual IP for the ASCS instance. And I do, so we'll go ahead and click on that and then click Next. The next dialog is asking if I want Lifekeeper to go ahead and automatically create some of the dependent file system resources. This would typically be used if you're using a shared disk. But again, I'm using a cloud file sharing service, so I'll click No. This dialog is just asking if I have any dependent file systems I want to add as dependencies. We don't, so we'll just click Next. And then finally, we'll just pick the default tag name for the resource. All right, so what we see here is Lifekeeper is going off, it's verifying the SAP installation. It's making sure that it can access all the utilities that it needs to access. It's making sure that all the supporting processes are running. And the part that it's waiting on right now is starting up the ASCS instance. And this takes about 30 seconds, after you send the instructions to SAP Start Service that you want to start it up. So we'll just fast forward through that. All right, so now my ASCS instance is protected on node A. But in order to switch over and fail over, I need to extend the protection to node B. So that's what we're doing here with this extend wizard. And right now it's going through a set of pre-extend checks, just making sure, again, the SAP installation looks good on node B, and it looks like I'll be able to successfully extend the resource. Okay, so the checks were successful, so we're able to go ahead and extend. And I'll just pick the default resource tag name here. Click Extend. And so now it'll take a few seconds, but it's going to create the resource to protect the ASCS instance on node B. And it's also going to go ahead and create equivalencies between the resources on node A and node B. And it's going to create the appropriate dependencies on node B for the ASCS resource on the dependent virtual IP resource that sits below it. So there we go. It's been extended. I'll click Finish, and it does one last hierarchy check just to make sure the dependency tree looks good. It does. So if we expand our hierarchy here, we see we have an ASCS resource, which is active on node A and standby on node B. So now we can go ahead and create a resource to protect our on-queue replication server, or ERS instance. And if you remember what we said earlier, since ASCS is running on node A, we're going to create the ERS instance on node B, right? Get it running on node B. So that's what we're doing here. We're just clicking through the same dialogues, but this time we selected the ERS 20 instance. And everything from this point on is exactly the same as creating the ASCS resource. So we're going to go ahead and fast forward through it, but it took me a little under 2 minutes to create the ERS resource hierarchy and extend it. Okay, so probably a little bit under 5 minutes total to create both of the resources. But now if you expand and look, you can see we've got ASCS running on node A. We've got ERS running on node B. And if we right-click the ASCS resource on node A and look at its properties, it'll show us the status of on-queue replication, which is the replication for the lock table. And you can see that it's currently active. So the lock table is actively being replicated from node A to node B. All right, the second thing I'd like to show is just how Lifekeeper detects a failure and acts on it. So I have forcefully rebooted node A, and we'll wait just a few seconds for Lifekeeper to pick up on the fact that node A has essentially crashed. But as soon as Lifekeeper picks up on that fact, you'll see the resources that were in service on node A start to come in service on node B. Right, so it just happened very quickly. The IP resources are already in service on node B. And so what it's doing right now is it's just starting up the ASCS instance on node B. And again, just like before, it takes about 30 seconds. So we'll go ahead and fast forward through that. All right, so at this point, Lifekeeper has successfully recovered the central services instance. But the issue now is just that the ASCS instance and the ERS instance are both running on the same server, node B. And if you remember what we talked about earlier, it's best if they're running on different servers. So as soon as node A has come back online, which it has at this point, and as soon as the ERS resource performs a health check on itself, which has happened now, it will detect that it's running on the same server as the ASCS instance, and then it will automatically migrate itself away, over to node A in this case. So you can see that's happened automatically. I haven't touched anything on this cluster. This has all happened automatically. And it's to the point where it's now bringing the ERS resource in service, which again takes about 30 seconds to start up the instance. So we'll go ahead and fast forward. All right, but so now we're back to the state that we were in to begin with, just reversed. So you can see now ASCS is running on node B, ERS is running on node A. And if I check the properties, you can see that the on-queue replication or the lock table replication is back to its active state. So we're back to a highly available state with the lock table being replicated from node B back to node A. All right, so now that we've seen how easy it is to create resources using Lifekeeper, and we've seen some of the monitoring and recovery features, I'd like to wrap up just with a few quick, customer success stories. So the first one I'll point out is in the top left, which is Zespri. And they are the world's leading manufacturer, distributor of kiwi fruit. And they actually run the largest SAP deployment on Azure worldwide. And they use SIOS Lifekeeper for Linux as part of their high availability stack. The second one I'll point out is on the right side, second from the top. We have a leading food packager who migrated their entire SAP workload from on-prem into AWS. And we're talking about over 200 servers. They're also using SIOS Lifekeeper for high availability. The last one I'll point out on this slide is just in the very top right, Toyogose. And I point them out just because all of the other ones on the slide are Linux environments. But you'll notice they're using DataKeeper Cluster Edition for Windows in Azure. And if you actually go and look at Azure's best practices guide for high availability for SAP in Azure, you'll see that DataKeeper Cluster Edition is actually a recommended solution when setting up ASCS ERS clusters on Windows. So I wanted to point that out. We have that customer, and we also have several other customers running the same configuration. Okay, so now just to wrap up, just want to point out, SIOS has highly flexible product line. Remember, runs on Linux, Windows, on-prem, virtualized, cloud, hybrid cloud, you name it. The products can go on every step of your cloud migration journey with you. We're also very reliable. We have intuitive SAP certified solutions to protect your SAP applications and databases. And finally, we've got over 20 years experience as a leader in high availability and disaster recovery. And combined with active partnerships with vendors like SAP and all the major cloud providers, that allows us to provide world-class customer service just in case any issues do arise. All right. So again, I'd like to thank you for attending the session today. If you have any questions, please feel free to reach out to any of the points of contact here on the slide, or if you'd like to get a free trial of our software. So again, thanks, and we look forward to hearing from you.